Hi everyone, we are ready for the next day in chapter 2, which is called Comparing and Ordering Rational Numbers. Take all this down on your table of contents. The objective today is to compare and order positive and negative rational numbers when they are written as fractions, decimals, and we see them as integers.
All right, the first thing we're going to talk about is when we need to compare numbers. So by comparing, we mean like which one is less than or which one is greater than. So we're going to see a lot of inequality symbols again throughout this lesson. So let's just read a little bit. And I know it's a little bit hard to read, but I'll read it out loud for you, so follow along. You can use a number line to compare rational numbers. For example, the number line shows that 1/8 is less than 1/4 because 1/8 is to the left of 1/4. Okay, so if you look here, we can see on our number line that we have 1/8 right here and 1/4 right here. So that's what that's talking about. Because the 1/8 is to the left, these are smaller numbers. As we go to the left of 0, they get smaller and smaller and smaller. All right, let's look at some of these. And we can use this number line that this assignment has given us. And it's kind of nice because it has all the numbers that we need on it. So we can just look up at the number line. Now remember that if a number line's not given to you, that it's okay to make one. And you might not have the exact numbers, but you could put some intervals that make sense to you. So number 1 says 5/8 compared to 2/3. So where is 5/8? Oh, there it is. And we can see that 2/3 is just to the right of it. So 5/8 is going to be smaller than or less than 2/3. All right, on to the next one. 3/8 compared to 1/3. So you can see we have 3/8 right here, and we have 1/3 just to the left of it. So in this case, 3/8 is going to be greater than 1/3 because it's further to the right of 0. Then the next one, 7/8 compared to 3/4. Here you can see 7/8. Here you can see 3/4. So 7/8 is bigger than 3/4. So 7/8 is greater than 3/4. Then we have 3/8 and 2/3. 3/8 is right here. 2/3 is over here, quite a ways to the right. So we know that 2/3 is bigger than 3/8, or 3/8 is smaller than 2/3. Then we have 3/4 and 2/3. And I know this is probably getting pretty redundant, but it's good to see all of the numbers here. 3/4 and 2/3. 2/3 is to the left, so it's going to be smaller. And so 3/4 is greater than 2/3. And the last one, 1/4 compared to 1/3. Okay, and we can see that 1/3 is to the right of 1/4. So 1/3 is greater than, or 1/4 is less than 1/3. So you can see here, and I went pretty fast through those. So if you need to re-listen to it or just kind of stop and absorb what we just did, definitely take a moment to do that.
Okay, when comparing two fractions, one of our methods that we can use is finding common denominators. And how we do that is we multiply our denominators to get the same denominator. Or, if you think back to the weird numbers video, getting the same disguise. So we first have to look at our denominator numbers and see what a common factor is between them. A common factor between 8 and 5 is the number 40. So I'm going to start building my fraction 40. And then I have to ask myself, well, what did I multiply by 5 to get 40? And hopefully you're thinking 8. And so whatever I multiply the denominator by, we also have to multiply the numerator by. So 3 times 8 is 24. Then on the other side, 8 times 5 gives us 40. And so I have to multiply the numerator by 5, and 2 times 5 gives us 10. Now this is super easy because all we do is compare our numerator numbers. So I'm looking at 10 and I'm comparing it with 24. Which one's bigger, 10 or 24? 24. So we insert then the less than sign. So 2/8, or in other words, 10/40 is less than 3/5 or 24/40. Okay, let's keep practicing. This next slide shows the same method, and really what we call that is the least common denominator. or LCD. And we are trying to get the same denominators. And so when we're given our fractions, sometimes there's also other denominators we could use. When I look at 4 and 6 to find a common denominator, I know I could pick 24, but there's actually a smaller number that they both have in common. Can you think of that number? Ooh, hopefully you're saying 12. So we're going to pick 12 for our denominator. So finding the smallest number that they both have in common. And then I know all I need to do with 6 is multiply it by 2 to get 12. So 3 times 2 is 6. And then to multiply 4, I multiply it by 3 to get 12. So 3 times 2 is also 6. And this one then is equal. 2/4 is the same thing as 3/6. If you even went back to that example, sometimes you could think back to your fractions and just reduce them at the beginning. So 2/4 isn't in its reduced amount. I know that 2/4 is 1/2 and 3/6 is also 1/2. And so we know that those are equal. So that's just another option for us as well, checking to make sure that they're in the reduced amounts. Okay, let's keep moving with our next example here. So what we see is 3 and 4/9, and we are trying to compare it with 3 and 3/4. When we have our whole numbers, pay attention to those. Since it's the same whole number, then we really have to concentrate only on these fraction pieces and find common denominators with our fractions. So common denominators between 9 and 4 is 36. So how did I get 36? Well, we multiplied 9 times 4, and then whatever I do to the denominator, we also do the same multiplication to the numerator. So 4 times 4 is 16. I don't want to forget about the 3, so I'm just going to rewrite 3. The next one where we have 3/4, we multiply that one by 9. So 3 times 9 is 27. 9 times 4 again is 36. And then we also have our big number 3. But really what I'm comparing, or what's helping me here, is focusing on these numerators again. And 27 is bigger than 16. So that means that 3 and 4/9 is less than 3 and 3/4. Okay, this next statement says, suppose you are comparing 2 and 3/8 with 3 and 3/5. Would you need to change denominators to common denominators to compare them? What do you think? Well, hopefully you said no, because if you pay attention to your whole numbers, you can just do the comparing there. We know that 2 is less than 3, so then 2 and 3/8 is less than 3 and 3/5. So keep that in mind. Don't forget about those whole numbers, because sometimes they jump out like that on us, and we then can just compare whole numbers. I'm going to add just compare whole numbers.
All right, let's get a little practice in using common denominators with a couple different situations. If we look at this first one, we have 1 and 4/5 compared to 1 and 8/10. So if we use common denominators, then let's look at those, and what do you notice? Always look to make sure if one goes into the other, because then you can use that as your denominator and save yourself some work. So we can see that 5 goes into 10. So we can use 10 as our common denominator, and we only have to change 1 and 4/5. So 5 times what will give you 10? Hopefully you said 2. So 4 times 2 will give me 8. So I have 1 and 8/10 compared to 1 and 8/10. So what do we know? That these are equal to each other. In our next example, we're going to have to change both of them. So we have -3/4 compared to -5/7. They're both negative, so we know we're going to have to be really careful when comparing them, because we're going to be to the left of 0 on the number line. So let's go ahead and change. So if I have 3/4, and first I need to find a common denominator between 4 and 7. Hopefully you're thinking 28. It's going to be the smallest one. And so 4 times 7 gives me 28, so 3 times 7 will give me 21. So on the left side, I have a -21/28. Then on the right side, I need to convert 5/7 to have a common denominator of 28. So 7 times 4 will give me 28. 5 times 4 will give me 20. So on the right-hand side, I have negative 20 over 28. And so now I need to think about it. Okay, which one of these is closer to 0? Because whichever one is closer to 0 is going to be greater than the other one. So if we just look at the numerators at this point, we can kind of ignore the denominators. And negative 21 is smaller than negative 20. So I'm going to put a less than sign in there. All right, our last one here, negative 3/4 compared to negative 5/6. Now be careful, this is a good example where using the least common denominator is going to be helpful. And sometimes I just look at the bigger denominator, so 4 compared to 6. I'm just going to count by 6s and ask myself if 4 goes into it. So does 4 go into 6? Nope. Does 4 go into 12? Because 6 times 2 is 12. Yes, it does. So that's an easy way to find the least common denominator. So I'm going to have to change both of these. Put 3/4 with a denominator of 12. 4 times 3 gives me 12. So 3 times 3 gives me 9. So this is going to change to negative 9/12. And then on the right-hand side, 5/6, changing that to a denominator of 12. 6 times 2 is 12, and 5 times 2 is 10. So this ends up being negative 10/12. And now because I have the same denominator, I can just look at the numerators. And again, we have both negative numbers. So you have to think about which one is closer to 0 because that's going to be the greater value. And negative 9 is closer. So negative 3/4 is greater than negative 5/6.
Okay, the next thing that we're going to look at when we compare and order our rational numbers is when we're given one of our numbers in a decimal format and one of them in a fraction one, that we kind of have a choice of which way we want to go. Do we want to write our fractions as decimals or do we want to write our decimals as fractions? And so we kind of have a choice this way. So I'll show you both ways. What I'm going to do is look at 3/5 and think about, okay, if I changed that one to get a denominator of in the tens place, all I would have to need to do is multiply both the numerator and the denominator by 2. When we get that, we have 6/10. And just as I say that, I write it as 0.6 because the 6 is in the tenths place value. And just like that now, and I'm going to pull this one down, I compared a decimal to a decimal. So they should relate back to our previous stuff with 2-1, where when we change forms between fractions and decimals, it just might appear for you right away. And you have the opportunity to maybe change a fraction to a decimal or change a decimal to a fraction. But in any ways, these are both equal when you compare them. And if I switch colors here and go the other route for you, so I'll rewrite the problem. If I decided to first change 6/10 into a fraction, then all I'd have to do is write it, or say it, write it, simplify it. So 6/10 looks like 6 out of 10. And then I can compare that with 3/5 by just changing that times 2. And so you're comparing 6/10 with 6/10 and they're equal. So both ways are right, and you have the choice of, do you want to go more decimal route or more fraction route? Okay, I'm going to practice this next example. First thing I'm going to do is notice that my fraction is, that my decimal is ending in the hundredths place value. So I'm going to change my fraction to end, or to get a denominator in the hundredths. And all I have to do is do that by multiplying it by 10. When I do that, we're left with a fraction that is negative 60 out of 100. And then I'm going to rewrite the decimal as a fraction by using the say it, write it, simplify it. So when I say that, formally, it's 53 hundredths. It is a negative, so it's going to be negative 53 out of 100. And I have to think about which numerator is bigger. Well, since we're dealing with negatives, remember that we want to be closer to 0. So negative 53 is bigger than negative 60. So in other words, negative 53 hundredths, written out as a decimal, is greater than negative 6/10. Looking at this next comparison over here to the right, you might notice fractions that you already know their decimal equivalencies. We call those our benchmark fractions, or ones that we've already memorized. So hopefully remember, what is the decimal equivalency to 1/4? Hopefully you're thinking 0.25. And so right away we could just change that to a decimal and compare it to 4/10. And when I compare then my tenths place value, even if I added a 0 to end in the hundredths, I'm really comparing just the tenths place. And 2 is less than 4, and so that means that 1/4 is less than 4/10. All right, in our final example, now this one tends to be tricky for some students because right away they want to say that these two items are equal. But what we have to be very careful with is that 2/3, remember, is really equivalent to 0.6 repeating. So what that means is if we stretched out 0.6 repeating, it would be a bunch of 6s forever repeating. So when I look at this 6th place value in the decimal, it has a 7, where the 6th place value in this one contains a 6. And so that's where the comparison has to happen. All the way down in the 6th decimal place value, away from 0 there, or away from your decimal point. And so these are not equal, but instead 2/3 is less than this 0.666667. Okay, go ahead right now, jot down any questions that you may have with any of the stuff that we did, and finish up your practice problems. We'll see you guys in class.